So really, I want to start the discussion for 9.2 here on page, I already forgot, 508, because everything you have seen above this so far in 9.2, well, above or previous, depending upon whether or not you have the PDF like I do, or the actual textbook would be that way. You get the idea. Everything that we have seen here is just a reminder that we can pass a reference from one function to another by using the ampersand, because what that does is it lets the environment know, okay, hold on, I'm not passing a copy of this, I'm passing an address, so that you have direct access to wherever it is in, let's say, an array, wherever it is the element, the address of that element in the array. So here, what you can see on the very top there of this particular screen cap is int, and then you see the asterisk and pointer. So we have seen the asterisk now being used in 3 different ways, and they all mean different things based on the context of things that are around them. So here, what you see on the top of, again, this is 508, is int, and then the asterisk indicates it's actually a pointer, and then the name of our integer value there is called PTR. So what this is not doing is creating an integer. What this is doing is creating a pointer that can reference an integer. Now, I know here at the get-go that's going to seem a little strange, but here's the rationale behind this. So instead of, again, forcing your program to always pass by value, because remember, again, copy of a 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 copy, and sooner or later, if you keep that idea of copy, copy, copy passing around your program, you're going to do one of 2 things. You are going to run dangerously close on how much available space you still have. As a matter of fact, we're going to see later in this chapter the idea of delete, like, yo, let's dereference some of this stuff so you can use it again, because the longer your program runs, the more space invariably it's going to take up. So the idea of having the address that points to, in this case, an integer value, saves you space that way. The other thing it saves you from doing is inadvertently shadowing with, one variable or the other. Remember, shadowing is what happens when we have the same variable name, but in fact they point to different variables, one from one function, one from another. So it's a mistake that, over the course of 276 in our previous class, you would have made at least a few times. Like, why isn't this number being returned? Well, because you're really working with the local copy of a variable instead of, the copy you thought you were working with over in main. This obfuscates that entirely, because if we're always using the reference, we're using its original address. There is no way to use a copy of that. So what that does is it prevents you from that shadowing mistake. So once you put those both conditions on top of one another, you now have something that's running faster with less, storage as a requirement, and you are reducing the probability or the possibility that perhaps you might be using the wrong variable. So that's what you see at the very top there, int, and then the asterisk, and then pointer. I didn't want to do this, and I apologize for making this video another 2.5 minutes longer now. You can see right here at the very top, you have int, asterisk, space, pointer. Some developers prefer to do it that way because what they're saying is this is an int pointer that we're calling pointer. It's the exact same thing. It's just that the space is either before or after the int with the asterisk. My suggestion to you is not to do it this way. It's 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 not the standard way. Not that there is a standard, because it's one of the things I know I've mentioned time and time again, which is the proper way to do this. Whoever signs your check gets to tell you this is the proper way to do this, because they're signing your checks over, right? But this one is 70-30. 70% of developers will do it the first way we saw: int space asterisk PTR. The other 30% will do it this way: int star space PTR. Look, I'm not a gambling man. I'm an odds. Which one of these two is the better odds for you? 70% or 30%? 70% every time. Do it the first way, not the second way here. In C++11, that's the version we are using via Replit. We also have this idea here of a null pointer, because it points to nothing, right? So it's kind of like saying, look, this is at address 0. What essentially you're doing here is you're defining a pointer, so you're actually giving it a value, so it's going to point there. It's actually not something we are going to continue to do here. This is just in here as like a noodle. This is something that you can do. It's something that was introduced, and I'm going to say relatively recently, right? The history of C++ is long, and C++11 has been here as long as I've been teaching at Rock Valley. So for the last 7 years, this is the version that we have been using. But I do feel like it's as good a time as any to mention, however, you may be involved with a project that is still running an older version of C++. For compatibility issues, for time issues, for investment issues, companies oftentimes will allow these older versions of software to sit there and languish forever. It's good to know that if you are using the idea of null pointer here in C++11, that will not scale backwards to previous versions. You will actually have to use null for that. Both of these, so the idea in C++11 of the null pointer and the idea of previous versions with null, both of those are included in the standard IO stream library. Double checking, that is a fact. So you are already including IO stream here. That's already being brought over as part of that library, so that it's there and available for you to use. So it's a fine idea, because this way, in the same way that we can initialize an integer, we can initialize a double value. And what we're doing is, okay, start here with a value, and as things are being assigned to it later on, that can change. So the null pointer is a similar idea. Is we can have an initialized pointer so that we're not running into the issue of what it is that we're going to do with that space that's already been allocated potentially by someplace else. So it's been shoehorned here into this piece of the chapter. And again, this is one of those good things to have germinate way back here in the back of your skull, and then one day you'll worry about them. It does not, however, show up again in any of our developments moving forward. So just a heads up.